All right, in this video, I'm going to illustrate how we can use the insights created by our machine learning algorithms into use and into how we can use them in real life. For the illustration purposes, I'm going to continue working on the data of heart disease and the results of the three machine learning algorithms that we've been talking on this data set, namely the decision tree, gradient boosting trees, and also the random forest. So we are not training these machine learning algorithms just for the sake of it. We are training them in order to then be able to use them. And in this particular context, if you're training a machine learning algorithm to be able to classify patients into those with heart disease and those without heart disease, you should be able to then use these algorithms to help you make decisions in the real world. And basically, what I'm going to do here is to create a fake data set that would be a data set that you would be receiving in real life in order to come up with some predictions based on the algorithms that you have created. So in order to create that fake data set, I'm going to basically create a random sample based on the actual data set that I have, and I'm going to call it raw data. So I'm going to type in raw_data is equal to heart, and remember, heart was the initial data set that we started working with, and then I use the sample, and what sample does is that it takes a sample for me from the original data set, which was heart. Now, one thing that I have to identify here is the proportion of the original values that I want to be included in my sample, and I just type in, say, 0.25. So what this does is that it's going to create a sample consisting of 25% of the original observations and puts it into the raw data. And because I want to be able to replicate this code and get the same sample every time, I'm going to use the random state. So let me just show you the this data set. So raw data dot head, and this is basically how this data set looked like. Basically, it is identical to the original data set. The only difference is that the observations are 25% in terms of the number of the observations. So it's a smaller data set, but it has the same number of columns. Now, what I have to do here is to be able to make some predictions. You see that we have the target, and the target is the actual values, right? So I want to make some predictions just like what I was doing with the testing data sets. And to do that, I have to first drop this target data set, because otherwise, if I want to make predictions, I will have some errors. So just to show you that error, let me first make some predictions, and let's say that I want to make predictions using the gradient boosted tree that I have. So I can type in gb3.predict and then give it the name of the data set that I want to make predictions based on, and this will give me an error saying that the number of the features is more than the number of the features that was expected. So it was expecting 13 features, whereas X dataset has 14 features, right? And that is because we have this extra target column that has to be dropped. So what I am going to do before running this predictions, let me comment this out, is to basically drop that raw dataset and basically create a new data set. So I'm going to call this raw data underscore feet, for raw data features. And that would be the same as the raw data. The difference is that I am going to drop the target column. Okay. So this is, okay. This needs to be in quotations like this. Okay, so you see that this is the raw data underscore feed, and that only includes the features. And by the way, again, it is still 25% of the total number of observations. Now, I can use this to make predictions. So instead of raw data, if I use raw data features only, then I would be able to make predictions, okay? So I'm going to make these predictions based on the trees that I have, based on the algorithms that I have trained, and put each of them in a new column, and then I'm going to merge them all together back with my raw data set. So one of the algorithms that I had created, the GB tree, was the gradient boosted tree. Then the other one was called the forest, which was the random forest. So I just say forest dot predict, and again with the same data set, raw data feed. And then the decision tree that I created before, one of them was tree 2, and again you got to go, let me see what happened. You got to go watch the previous videos if you need any details about training these data sets or training these algorithms. So tree2 dot predict, and again the same thing. I'm going to give them a name. So for the GB3, I call it GB3 underscore pred is equal. So basically GB3 underscore pred is the predictions that the algorithm makes based on the gradient boosted tree. And then I call this other one forest underscore pred. And then I call this other one tree underscore pred. Okay, so now I have created 3 columns, right? Each of them would consist of the predictions made based on the corresponding machine learning algorithm. Now, what I have to do is to go and put them back at the very end of the original data set that I had, right? So the original data set is this raw data, right? I want to add these as 3 new columns at the very end of my data set. So, and that is very, very easy. I am going to say that the new data set is going to have 1 new column. Or basically, the original data set is going to have 1 new column, and I call this column, say, gradient boosting predictions, okay? And I say it is equal to this column, okay? And then I just basically do the same thing for the other one. So one of them was gradient boosting, the other one was random forest predictions. So it would be the forest predictions, and then the other one is going to be decision tree predictions, which are going to be the tree prediction. And then just so we have an idea of how the data looks now, I'm going to print the head. And now you see that up to here is the original data that we had, right? The raw data set. And now we have 3 additional columns: gradient boosted predictions, random forest predictions, and decision tree predictions, which are either 0 or 1, depending on what the prediction was for that particular thing. So one thing that you would notice immediately is that these different machine learning algorithms do not agree with each other, right? So for example, for the first observation that we have here, The random forest has predicted the person to have heart disease because it's 1, whereas the other 2 algorithms have predicted that the person is not having heart disease, or classified the person as no heart disease. In some other cases, they are getting the same results. So in the second observation, everybody is 0, and in the third observation, it's the same. But then you see that here you have 2 zeros and 1 1, right? So what I want to do here is to basically create an ensemble of all these 3 different predictors, right? Meaning that I want to have a new prediction that takes the results of these 3 different predictions and gives me an even better prediction, right? And one thing that I can think of is to see what is the majority, right? So I'm going to create a new column that is basically going to look at the predictions from these 3 machine learning algorithms and identify what is the most frequent prediction among them as its own prediction, all right? Think of it as the recommendations of 3 different experts about a decision, and each of them is giving you some recommendation, and you're going to look at the recommendations of all the 3 and go with the recommendation that is most common among them, meaning that if all of them say something, then you would do that. But if, say, one of them says no, the other 2 say yes, then you're going to go with yes. And if 2 of them say no and only one of them say yes, then you're going to go with no because 2 out of 3 said no. And basically what I'm going to do here is to create a new column. And I'm just going to call it AVG, standing for average. So I just say raw data and create a new column called average is going to be the sum of these 3 columns. So the first column plus the second column plus the third column make sure that you put all of them in a parenthesis and then divide it by 3. And again, just to see what we've done here, I'm going to print the head. So you see that you have the average, and for the first observation is 0.33 because it's 1 divided by 3, right? So it's going to be 0.33. Basically, what we're going to say is that as long as the average is larger than, say, 0.66, you're going to go with yes, and otherwise 0. What does it mean? It means that, as long as none of the 3 machine learning algorithms or one of them only give a prediction of 1, it means that the other 2 are giving the prediction of 0. And since you're going to go with the majority, your final decision should be 0. Okay, so we have to do that using the NumPy. So I am going to create a new column called majority. So I just say raw underscore majority is going to be equal to, raw data. Then the majority column. Is going to be equal to, here we are going to call NumPy and use the where function built into the NumPy. So basically we were saying that np.where, and then we say that this raw data, the the column that we're working with is the average. So AVG is greater or equal to 2 over 3. The majority is saying 1, otherwise 0. Okay, so let me explain this here. So we are creating a new column called majority that is going to be added to the raw data set, and that is going to be equal to 1 if the value of average is larger or greater or equal to 2/3 and 0 otherwise. So you see here the majority. Here for the first example, for the first observation, you have 0, 1, 0, right? So 2 zeros and 1, 1, and then the majority is going to be 0, right? In contrast, in this one, because the three of them has said 1, then you have 1. Here, you again have 2 zeros and 1, 1, so you're going to have the majority be equal to 0. And the way that I created it is just by creating a new column called average and using it as a middle step to come up with the majority. All right, so now I basically have 4 classifications for each observations. 1 based on gradient boosting, 1 based on random forest, 1 based on decision tree, and finally 1 based on the consensus or the majority vote of these decision trees. And what I want to see is whether or not this majority is any better than the other 3 algorithms alone. So I'm going to use the trick that I used in the iris classification example, and again use NumPy. So what I'm going to do is to say np dot mean of cases where the column majority in the raw data, Let me just make sure that I'm not having any problems here. So where raw data majority is equal to raw data target, that would be the accuracy of my majority algorithm. And I'm going to use that here. Sorry, np dot mean. Okay, so this np dot mean would be the accuracy of your majority algorithm. And basically what it does is that it looks at the average of instances where the majority is equal to the target, meaning that you have made correct predictions. Whether it's 0 or 1, it doesn't matter. As long as it's correct, that would be your accuracy, all right? It's 0.88. Now, to make it a little bit nicer, I'm going to print it with a description. So I say print, make sure that you have the parentheses. So we have this value inside the print. And one thing that I'm going to do is to add a description inside quotations. So I just say majority accuracy is, and then I add the plus sign. And remember that whatever you put in the string, you put in the print function should have a string. So use the str functions within the print, and then make sure that you also have all of the parentheses that you need. So it says majority accuracy is 0.88, and then I'm going to just use the same thing for the other algorithms. So we would have gradient boosting, accuracy is equal to, instead of the column majority, you should use the column gradient boosting predictions. So when you do this, it gives you the accuracy for the gradient boosting, and do the same thing for the random forest as well. So random forest accuracy is equal to average number of times where the predictions from random forest is equal to the target. And finally, the decision tree. So decision tree accuracy is equal to the number of times where the predictions from the decision tree is equal to the actual values. And let's print them. And now let's look at this. It's very, very interesting. So you see that the gradient boosting tree gives you an accuracy of 85, which is very close to the accuracy that random forest gives you. And they are both much higher than the decision tree. This is all what you had expected, right? So you have decision tree, and then superior to decision tree are random forest and gradient boosting. But what is very interesting is that the majority accuracy is 0.88, right? It is 3% in absolute value more than the other best algorithm that you had, which was the gradient boosting, right? So this is an example of how you can create your own ensembles of other decision trees or other machine learning algorithms that you have created. And remember, it does not need to be an ensemble of different variations of decision trees. You could have had, say, a logistic regression or a KNN, and then you could create an ensemble of their predictions in the exact same way that I just created this particular ensemble. And finally, the very last thing that I want to tell you is that, hey, you want to, for example, give this data set along with the predictions back to the person who has to make decisions. And you can export it to Excel very, very easily. So you just type in the raw data. Basically, that's the data frame that you want to export. And then you use the to_Excel. That's basically the built-in function here. And then you give it a name. Let's say I'm going to call it predictions. Okay, make sure that you use the .xls x at the end. And what happens is that once I run it, an Excel sheet called predictions is going to be created inside the same folder which this Jupyter notebook is at. And it's going to be called predictions, and it's going to basically be a copy of the raw data that I have. So let me run this, and if I open my the same folder where I have this data, this notebook, sorry, it would be heart disease, and you see that the predictions, this is the predictions data set, right? So note that you have these new columns, so gradient boosted predictions, forest predictions, decision tree predictions, the average, and the majority. These are all the columns that we created and added to the original data set, which was up to here, right? So for each patient, there is going to be a prediction that you have created here, and then you can give this data set to whomever has to make decision based on this, right? So that is how you can put the results of your decision trees and other machine learning algorithms into use for real world applications.